So problem 20. This one is tricky, actually. Okay, so a unit square is rotated 45 degrees about its center. What is the area swept out by the interior square? So what's happening here is that we have this square, and then we rotate it. And we rotate it. And I'm realizing now this is not a square, so I'm gonna have to redraw this. Smush it. I cannot smush it. Okay. Just gonna do this. Probably can't. You can't really do this with a ruler on paper, actually. Okay, we now have a perfect square. And so what the problem asks us is when you rotate this thing 45 degrees, like that, how much area is swept out? So I'm just gonna label these points, and then we rotate. Right. It's a cool looking diagram. And so yeah, firstly, you do have immediately that like this like radius here sweeps out all of this arc. And like along these angles, that is 100% guaranteed to be the farthest out that you're going to get. Like between B and B prime, the farthest out you can get is square root of 2/2, because that's like the farthest away from the center of the square you can get. And all of that is achieved like as B passes through. And it's the same for like C to C prime, D to D prime, A to A prime, all of those arcs. And so now the tricky part is A prime to B, for example. Like what kind of shape do we have here? What marks the boundary of like the region that got swept out? And in fact, I claim that the region that gets swept out is in fact these endpoints. It's in fact that everything out here can't be reached during the sweeping. And why is that? Well, it's because really what sweeping represents is that you take a square, you select some 45-degree angle. That's not a good example. You select some 45-degree angle, and then you find the longest length in that 45-degree angle range. And when you don't contain square root of 2/2, the longest lengths are going to be at one of these edges. And one of these edges represents this side. One of these edges represents this side, and one of these edges represents that side. So yeah, we do in fact have that. This segment here marks the outer boundary of the region swept by the interior of the square. Everything outside of it can't get hit. And if you try to play through like mentally, like imagining like the rotation a couple times, it makes sense, because I'll draw another square, I guess. It's kind of hard to visualize. Like as you rotate, nothing will really, the short parts, as you rotate, actually, wait, this is a good idea. As you rotate, as like you're halfway through the rotation, for example, halfway through the rotation, the line, that side length is like, it goes through that point, but it's not like, it'll always just be touching at that point, but it won't be able to, it won't be going as far out. Yeah. So we in fact have that. We're just now instead trying to find the area of this region. We're trying to find the area of this region. The region which my original diagram is so much better. I'm just going to keep using it. We're trying to find the area of this region. Okay. Yeah. So we can find the area of like the slices. This isn't too bad. This is 1/8 of a full circle, which equals 1/8 times pi r squared. And the radius of the circle is square root of 2/2. By Pythag. So it's pi over 16 for each slice. And then for each like O, B, P, A prime, like the area of that figure is going to be 2 times OPB. Oh, in fact, I found it easier to solve for this area. So I'm gonna change that. So the area of OB prime PC is equal to 2 times the area of OB prime P. And we can solve for the coordinates of P, which will be 1/2 because it's a unit circle. It's because it's a unit square. So like the line BC is 1/2 a unit from O if we let O be the origin. And then its X coordinate is going to be, its Y coordinate is going to be, negative signs are hard, negative square root of 2 minus 1/2. Because we have that along this line, B prime, C prime. The difference between X is √2/2 more than the Y coordinate. And then so because of that, the area of OBP prime will be 2 times the base, which is √2/2, times the height, which is √2 minus 1/2, all over 2, which will be equal to 2 minus √2/4. And so thus the total area is equal to 4 of the slices plus 4 times like OB prime PC, which is equal to pi over 2 plus 2 minus √2. Oh, wait. Pi over